At 17 minutes past 8 on a July evening, the sky over the Atlantic Ocean turned white. A ball of fire appeared where no fire should have been, thousands of feet above the water south of Long Island, and then it fell. It fell in pieces. 230 people had been alive seconds earlier. They were flying to Paris. They were going to weddings, to holidays, to business meetings, to new chapters of their lives. And then they were gone. Not slowly, not with warning. In an instant that split the air and lit the ocean, what happened to TWA Flight 800 would become the subject of one of the most expansive, most exhaustive, and most controversial aviation investigations in American history. It would take more than 4 years to reach a conclusion, and for many, even that conclusion would not be enough. The aircraft was a Boeing 747-131, one of the most recognizable airplanes ever built. Its registration was N93119. It had entered service with Trans World Airlines in 1971, a quarter century before that July evening. By 1996, the airframe had accumulated over 93,000 flight hours and nearly 17,000 flights. It was old, but it had been maintained. It had passed inspections. It had been deemed airworthy. The 747 was, and remains, one of the most successful wide-body aircraft in the history of commercial aviation. It was designed with redundancy, with multiple hydraulic systems, with structural tolerances meant to withstand decades of service. TWA had been operating it on transatlantic routes for years. There was nothing unusual about this particular airplane being assigned to this particular flight. TWA Flight 800 was a regularly scheduled international service from John F. Kennedy International Airport in New York to Charles de Gaulle Airport in Paris, with a continuing leg to Rome. On the evening of July 17, 1996, the flight was carrying 212 passengers and 18 crew members. The passengers represented a cross-section of ordinary life. There were high school students from a French club in Montoursville, Pennsylvania, 16 teenagers and 5 chaperones traveling together for a trip to France. There were families. There were business people. There were tourists. Some were American. Some were French. Some were from other countries entirely. The flight crew consisted of 4 members. Captain Ralph Kevorkian, who had approximately 18,800 hours of flight time, was seated in the left seat performing pilot flying duties. He was undergoing a routine line check overseen by Captain Stephen Snyder, a Czech airman with over 17,000 hours, who occupied the right seat. Flight engineer Richard Campbell, also a Czech airman, sat in the cockpit jump seat. And flight engineer trainee Oliver Crick, 25 years old and on just the 6th leg of his initial operating experience with TWA, occupied the flight engineer's station. Campbell was monitoring Crick's performance. The cockpit crew had the qualifications and the hours expected of a transatlantic command. The flight had been delayed. It was supposed to depart earlier in the evening, but a disabled piece of ground equipment and a passenger baggage mismatch pushed the departure back by over an hour. The aircraft pushed back from Gate 27 at approximately 8:02 p.m. Eastern Daylight Time. It taxied, took the runway, and lifted off at 8:19 p.m., heading east over Long Island toward the open Atlantic. The evening was warm. Visibility was good. The air along the departure corridor was calm. It was, by every standard measure, an unremarkable summer evening for a transatlantic departure from New York. The climb was normal. Air traffic control communications were routine. The aircraft passed through successive altitude assignments without incident. At approximately 8:31 p.m., 12 minutes after takeoff, TWA Flight 800 was climbing through approximately 13,700 feet over the Atlantic Ocean, roughly 8 miles south of the Long Island coastline near the village of East Moriches. The cockpit voice recorder captured the crew in normal conversation, with no indication of concern, no alarm, no distress of any kind. About 2 minutes before the end of the recording, Captain Kevorkian remarked on an anomalous reading from a fuel flow indicator. It was a brief observation, not an emergency. And then the recording stopped, not with a warning, not with a call. The recording simply ended with a fraction of a second of sound that investigators would later identify as the onset of a catastrophic event. At that moment, the center wing tank of the Boeing 747 exploded. The explosion was not external. It originated inside the aircraft, within the center wing fuel tank, a large structural tank located between the wings and beneath the passenger cabin. The force of the explosion was immense. It blew apart the forward section of the fuselage from the rest of the aircraft, the nose, the cockpit, the first-class cabin, and a portion of the forward fuselage separated and fell toward the ocean in a trajectory distinct from the rest of the aircraft. The remaining structure, now without its forward section, continued to move through the air momentarily, driven by the still operating engines and aerodynamic forces acting on the airframe. Fuel from ruptured tanks ignited. A massive fireball formed. Witnesses on the ground, on boats, and along the Long Island shoreline saw a streak of light in the sky, followed by an explosion and a shower of burning debris falling toward the water. Some described it as a firework. Others described it as something they could not explain. Several hundred people witnessed some portion of the event. Their accounts would later become one of the most debated elements of the investigation. The wreckage struck the Atlantic Ocean in a debris field that stretched across several miles. The water in that area was approximately 120 feet deep. The impact was not survivable. All 230 people on board TWA Flight 800 were killed. At the time, it was one of the deadliest aviation disasters in American history. The loss was staggering. An entire high school French club from a small Pennsylvania town was gone. Families were shattered in an instant. The news spread quickly. By nightfall, the nation knew that a 747 had fallen from the sky just off the coast of New York. The response was immediate and massive. The United States Coast Guard, the Navy, local police, and emergency services converged on the water south of Long Island within minutes. A New York Air National Guard helicopter crew witnessed the explosion from about 8 miles away and arrived at the scene while debris was still falling, forcing them to pull back. The first vessels to arrive found burning fuel on the surface of the ocean, scattered debris, and no survivors. The scale of the disaster zone was immense. Wreckage was spread across a wide area of ocean floor. Personal belongings, aircraft components, and human remains were commingled in the water and along the seabed. Recovery operations began almost immediately and would continue for more than 10 months. Divers worked in difficult conditions, low visibility, strong currents, and the emotional weight of recovering the dead from a shattered aircraft on the ocean floor. Over the course of the recovery effort, more than 95% of the aircraft's structure was retrieved from the Atlantic. It was one of the most thorough wreckage recoveries ever attempted. The investigation was led by the National Transportation Safety Board, the NTSB, as is standard for civil aviation accidents in the United States. However, this case was different from the start. Given the catastrophic and sudden nature of the explosion, the proximity to New York City, and the geopolitical climate of the mid-1990s, the Federal Bureau of Investigation launched a parallel criminal investigation. The FBI's involvement was predicated on the possibility that TWA Flight 800 had been brought down by a criminal act, either a bomb or a missile. For the first 16 months of the investigation, the NTSB and the FBI worked alongside each other, sometimes cooperatively, sometimes in tension. The dual-track investigation created complications, as evidence handling, media access, and public communications were influenced by two agencies with different mandates, different cultures, and different standards of proof. The wreckage was transported to a former Grumman aircraft facility in Calverton, Long Island, where investigators undertook an extraordinary reconstruction. Piece by piece, the recovered sections of the Boeing 747 were laid out and reassembled on a metal framework. Over time, the reconstruction grew to include major portions of the fuselage, the wings, and the center wing tank structure. It was painstaking, meticulous work. Every fragment was cataloged, examined, and placed in its relative position within the aircraft. The goal was to read the physical evidence, to let the wreckage tell the story of how and where the aircraft had come apart. The cockpit voice recorder and the flight data recorder were both recovered from the ocean floor by Navy divers about a week after the accident and sent to the NTSB laboratory in Washington for analysis. The cockpit voice recorder captured normal crew conversations up until the final fraction of a second. There was no distress call. There was no warning from any system. The flight data recorder showed normal engine performance, normal flight parameters, and no anomalies in any recorded system prior to the event. Both recorders ceased functioning at the same instant, consistent with the sudden and catastrophic loss of electrical power. The data told investigators what had not happened. There had been no engine failure, no control malfunction, no gradual system degradation. Whatever destroyed the aircraft did so with a speed and violence that allowed for no crew response whatsoever. The center wing tank became the focus of the investigation early on. Examination of the recovered tank structure revealed that the interior surfaces bore evidence of an overpressure event, an explosion originating from within the tank itself. The deformation patterns on the tank walls, the fracture characteristics of the metal, and the soot and heat damage were all consistent with a fuel-air explosion inside the center wing tank. This was a critical finding. It meant the explosion was internal to the aircraft, not the result of an external impact such as a missile warhead or an external bomb blast. But understanding that the center wing tank had exploded raised an immediate and deeply troubling question: why the center wing tank of a Boeing 747 is designed to hold fuel. On this particular flight, the tank held only about 50 gallons of Jet A fuel, a residual amount from previous operations. The tank was nearly empty of liquid fuel, but it was not empty of fuel vapor. That distinction turned out to be everything. Jet A fuel, the standard aviation kerosene used by commercial airlines, has a flash point, a temperature above which its vapors become flammable when mixed with air in the right concentration. Under normal conditions at sea level, Jet A is relatively difficult to ignite. But conditions in the center wing tank of TWA Flight 800 were not normal. The aircraft had been sitting on the tarmac at JFK for approximately 2.5 hours on a hot July day, with ambient temperatures in the low 80s Fahrenheit. More critically, the aircraft's 3 air conditioning packs, the large pneumatic units that cool and pressurize cabin air, were located directly beneath the center wing tank in an uninsulated compartment. These units generate significant heat during operation, with surface temperatures reaching hundreds of degrees. While the aircraft sat at the gate with the packs running, that heat radiated upward into the floor of the center wing tank, warming the residual fuel and the air inside the tank well above the temperatures at which Jet A vapor becomes flammable. Testing later estimated that by the time TWA Flight 800 reached approximately 13,700 feet, the fuel-air mixture inside the center wing tank had entered the flammable range. The conditions for an explosion existed. All that was missing was a source of ignition. The NTSB concluded that the probable cause of the explosion was the ignition of the flammable fuel-air mixture in the center wing tank. But identifying the ignition source proved to be one of the most difficult challenges of the entire investigation. Investigators examined every possible electrical component, every wire, every connector, every pump, every sensor that existed within or near the center wing tank. They tested and analyzed hundreds of components. They studied the aircraft's electrical system in extraordinary detail. They found evidence of chafed wiring and degraded insulation in several areas of the fuel quantity indication system, the network of wires and probes that measure the amount of fuel in the tank. Some of these wires ran through or near the center wing tank. The investigation found that over the 25-year life of the aircraft, wiring had been subject to wear, maintenance handling, and environmental degradation. Short circuits in this wiring could, under certain conditions, produce sufficient energy to ignite a flammable fuel-air mixture. There were also suggestive circumstantial details. The recovered fuel quantity gauge for the center wing tank displayed a reading inconsistent with the amount of fuel that had been loaded, which could indicate an electrical anomaly in the fuel quantity indication system wiring. Captain Kevorkian's remark about a fuel flow indicator behaving strangely, captured on the cockpit voice recorder roughly 2 minutes before the end of the recording, was noted by investigators as potentially related, since fuel flow indication and fuel quantity indication wiring ran through common raceways in the aircraft. These were not conclusive, but they pointed in the same direction. However, the NTSB was unable to identify the specific ignition source with certainty. Not all wiring and components were recovered from the ocean. The board's final report, issued in August of 2000, stated that the probable cause of the accident was an explosion of the center wing fuel tank resulting from ignition of the flammable fuel-air mixture in the tank. The source of ignition energy for the explosion could not be determined with certainty, but of the sources evaluated by the investigation, the most likely was a short circuit outside the center wing tank that allowed excessive voltage to enter the tank through electrical wiring associated with the fuel quantity indication system. This was an unusual conclusion for the NTSB, an agency that typically identifies causes with specificity. The acknowledgement that the exact ignition source could not be pinpointed reflected both the severity of the destruction and the limits of the physical evidence that survived it. The FBI's criminal investigation ran parallel to the NTSB's work for 16 months. Agents tested for explosive residues on wreckage components. They interviewed hundreds of eyewitnesses. They pursued leads related to possible missile strikes and bomb placements. Trace amounts of explosive residues were found on some wreckage pieces, but the FBI ultimately determined that these residues were consistent with contamination, possibly from a military canine training exercise that had been conducted aboard the aircraft prior to the accident flight, or from other incidental sources. No physical evidence of a bomb or a missile was found. No credible intelligence linked any individual or group to an attack on the aircraft. In November 1997, the FBI officially closed its criminal investigation, concluding that there was no evidence of a criminal act, but the eyewitness accounts remained a source of intense public debate. More than 250 witnesses reported seeing a streak of light rising from the surface or from a low altitude before the explosion. Many described what appeared to be a missile or a rocket ascending toward the aircraft. The NTSB addressed these accounts extensively. The board commissioned the Central Intelligence Agency to produce an analysis and animation of the aircraft's breakup sequence. The CIA's analysis concluded that what witnesses had seen was not a missile ascending toward the aircraft, but rather the aircraft itself, or burning fuel, rising and arcing after the initial explosion and the separation of the forward fuselage. The forward portion of the aircraft fell away, lightening the remaining structure, which then pitched upward and may have climbed several thousand feet while trailing fire before breaking apart completely. According to this analysis, witnesses on the ground, viewing the event from a distance and at an angle, could have misinterpreted this sequence as a rising streak of light. This explanation did not satisfy everyone. Some witnesses maintained, then and for years afterward, that what they saw was clearly an object ascending toward the aircraft from below, not debris falling or an aircraft climbing. Several independent investigators, retired military personnel, and journalists challenged the official findings, arguing that the eyewitness evidence was consistent with a missile strike and that the government's investigation had been compromised by institutional pressures. These claims were examined and re-examined over the years. In 2013, a former NTSB investigator and a documentary filmmaker petitioned the NTSB to reopen the investigation based on what they described as new evidence, including analyses of the debris field and witness testimony. The NTSB reviewed the petition and declined to reopen the case, stating that the petitioners had not presented evidence sufficient to warrant a new investigation. It is important to distinguish between what the investigation found and what it did not find. The NTSB found conclusive physical evidence that the center wing tank exploded from within. The pattern of structural failure, the metallurgical evidence, the sequence of breakup recorded by radar and debris distribution all pointed to an internal fuel-air explosion as the initiating event. No physical evidence of a missile impact was found. No warhead fragments were recovered. No missile components were identified among the hundreds of thousands of pieces of wreckage. No blast damage consistent with an external detonation was found on the fuselage skin. The physical evidence, examined by hundreds of investigators over 4 years, consistently pointed to one conclusion: the aircraft was destroyed by an internal explosion in the center wing fuel tank. What the investigation could not do was explain exactly how that explosion was ignited, and it is this gap, this acknowledged uncertainty at the heart of the official finding, that has sustained doubt and alternative theories for decades. In the absence of a definitively identified ignition source, some observers have found it difficult to accept the conclusion. The NTSB was transparent about this limitation. The board did not claim certainty where certainty did not exist. It stated a probable cause and identified the most likely mechanism, but probable is not certain. And in a case that killed 230 people and was witnessed by hundreds more, the space between probable and certain has been filled with questions that may never be fully answered. The consequences of TWA Flight 800 for aviation safety were profound and far-reaching. The NTSB issued a series of safety recommendations that fundamentally changed how the industry addressed the risk of fuel tank explosions. The most significant of these was the recommendation that the Federal Aviation Administration require the reduction of flammable vapors in fuel tanks. This led, after years of regulatory development, to the FAA mandating fuel tank inerting systems on many commercial aircraft. A fuel tank inerting system, often called OBIGS, or Onboard Inert Gas Generation System, works by replacing the oxygen-rich air in fuel tanks with nitrogen-enriched air. By reducing the oxygen concentration below the level needed to sustain combustion, the system makes it effectively impossible for a fuel-air explosion to occur inside the tank, regardless of the temperature or the fuel-air mixture ratio. This technology was not new. Military aircraft had used inerting systems for decades. But the commercial aviation industry had resisted the cost and complexity of implementing it on civilian airliners. TWA Flight 800 changed that calculus. The FAA's fuel tank safety rule, finalized in 2008, required inerting systems on newly manufactured aircraft and retrofit installations on existing fleets for aircraft with heated center wing tanks. The investigation also led to improvements in fuel tank wiring standards, inspection procedures for aging aircraft wiring, and new requirements for the design and maintenance of fuel quantity indication systems. The FAA issued airworthiness directives addressing wiring degradation, insulation concerns, and the separation of power supply wiring from fuel system components. These were not abstract regulatory changes. They were direct responses to the specific vulnerabilities that the TWA Flight 800 investigation revealed. Every commercial passenger who has flown on a modern airliner with a fuel tank inerting system owes a measure of safety to the investigation of this disaster. It is not an exaggeration to say that the lessons of TWA Flight 800 have likely prevented future explosions. But the legacy of this case extends beyond technical fixes. It revealed the challenges of conducting a transparent investigation under intense public scrutiny and media pressure. It exposed the difficulties of coordinating between a civilian safety investigation and a criminal probe. The FBI's parallel involvement, while understandable given the circumstances, created friction, delayed the release of findings, and contributed to public mistrust. The CIA's involvement in producing a public animation to explain the eyewitness accounts was criticized by some as an inappropriate role for an intelligence agency in a domestic aviation investigation. The entire process highlighted the need for clear protocols governing multi-agency investigations and for better communication with the public and with victims' families during prolonged and complex inquiries. One concrete outcome was a memorandum of understanding between the FBI and the NTSB regarding the handling of future investigations involving potential criminal acts. The families of the 230 victims endured years of uncertainty. Many attended public hearings. Many pressed for answers. Some found the NTSB's conclusions satisfactory. Others did not. For the families of the 16 students and 5 chaperones from Montoursville, Pennsylvania, the loss was not just personal but communal. A small town lost an entire generation of young people in a single night. Memorials were built. Scholarships were established. But the grief was permanent. The families of TWA Flight 800 became, in many ways, advocates for aviation safety, pushing for the very reforms that the investigation eventually produced. Their loss was not abstract. It was specific, personal, and devastating. And it is their loss, above all, that gives this case its weight. For years after the disaster, the reconstructed wreckage of TWA Flight 800 served as one of the most important teaching tools in aviation accident investigation. Originally assembled at the Calverton facility, it was later moved to the NTSB's training center in Ashburn, Virginia, where it was used to educate thousands of investigators from around the world. It was one of the only fully reconstructed accident aircraft in existence. In 2021, the NTSB announced plans to decommission the reconstruction, citing advances in digital documentation and the expiration of its facility lease. The wreckage was ultimately destroyed in 2023 in accordance with an agreement with victims' families that it would never become a public exhibit. The decision drew both support and opposition. Supporters argued that the wreckage had served its purpose. Opponents, including some family members and independent investigators, argued that the wreckage should have been preserved, particularly given the unresolved question of the ignition source. The NTSB proceeded, stating that the investigation was closed, the findings were final, and the wreckage had been thoroughly documented using modern scanning technology. There is a particular kind of tragedy in an aviation disaster that occurs not because of a single dramatic failure, but because of a slow accumulation of overlooked risks. The center wing tank of a Boeing 747 was never designed to be a hazard. It was designed to hold fuel. But the interaction of hot air conditioning packs beneath the tank, the presence of residual fuel vapor, the lack of any inerting system to prevent flammable mixtures from forming, and the potential for degraded wiring to produce a spark. These were conditions that existed not on one flight, but on thousands of flights over decades. TWA Flight 800 was not unique in having a warm center wing tank with a flammable vapor mixture inside. What was unique was that, on this flight, on this evening, something provided the energy needed to ignite it. The NTSB's investigation revealed that the entire fleet of 747s and many other aircraft types had been flying with this latent vulnerability for years. The disaster was not an anomaly. It was the realization of a risk that the industry had tolerated, implicitly, for far too long. The case of TWA Flight 800 is closed. The official cause is established. A fuel-air explosion in the center wing tank, most likely ignited by a short circuit in the fuel quantity indication system wiring. No evidence of a criminal act was found. The investigation produced safety reforms that have made commercial aviation measurably safer. These are the findings as determined by the investigating authorities after more than 4 years of work, thousands of interviews, hundreds of thousands of examined components, and the most comprehensive aircraft reconstruction in history. And yet, the case endures in public memory as something unfinished, not because the physical evidence is ambiguous. It is not, but because the precise ignition source was never identified with certainty, and because hundreds of witnesses saw something in the sky that night that they struggled to reconcile with the official explanation. These are not unreasonable concerns. They reflect the honest limits of what even the most thorough investigation can determine when an aircraft is destroyed with such violence and falls into the ocean in pieces. Some questions, in aviation and in life, do not yield clean answers. The responsible course is to acknowledge what is known, to be honest about what is not, and to ensure that the lessons paid for at such cost are never forgotten. On the evening of July 17, 1996, 230 people boarded an airplane bound for Paris and Rome. They trusted the systems that were supposed to keep them safe. They trusted the aircraft, the crew, the maintenance, the regulations, and the oversight that governed commercial aviation. That trust was not misplaced in any obvious or negligent way. The aircraft was legal, the crew was qualified, the systems were functioning, but inside the structure of the airplane, in a place no one was monitoring, a condition existed that should not have been tolerated. A fuel tank was hot. The vapor inside it was flammable, and somewhere, through a mechanism that investigators believe most likely involved degraded wiring in the fuel quantity indication system. Sufficient energy reached the vapor. The result was 230 deaths, more than 4 years of investigation, and a set of reforms that ensured this particular failure would not happen again. That is the legacy of TWA Flight 800, not conspiracy, not mystery, but a hard lesson learned at an unbearable price about the dangers that hide in the ordinary, in the spaces between what we inspect and what we assume.